So, our last mini topic in 3 days, and we are doing I don't even know if it's probability. I think it's also statistics. We have statistics. Right now there is a test made up, but we're talking tonight about what we're actually doing, not tonight, this afternoon, about what we're actually doing with it. My people that missed last class will take the quiz the second half, so I can at least get some of the notes for you guys. And then you can look over stuff at lunch, hopefully to help yourselves. Okay. So in the notes, I attempted to, where there was a lot of writing, type it out, because we all know my handwriting's super messy and it's hard to read. So there's going to be sections where I typed it out so that you guys can actually read it instead of my handwriting. All right. All right, so I'll give you guys a second to get this information down. Let me know if I need to zoom in, because I picked a smaller font. Am I stuck together? Literally or figuratively? Literally. Okay. My brother always asks me that. Are you finding it annoying? No. Sounds like that to me. All right. So, here are our answers. The last one is a trick question. You can't find the area of a straight line. So at x equals 3, there's no actual range, which if you take AP statistics, she'll get into discrete and non-discrete on why that is 0 for that one. So that one's a trick question. If you guys don't know enough about stats, we will do it. That's not an actual range from this to this. So okay. Any questions on those ones? If you're good, that's the bottom of your page, right? Flip the page if you're good. All right, what I want you guys to try to do for numero uno is see if you can draw your graph this time. So draw this based on the information that you have. See if you can set it up based on what the story problem is about coffee. So see if you can set up your picture. All right, what's my range this time from what to what? 10 to 13, so if I want to write in my 11 to 12, I can. Okay, so then what's the height going to be? How'd you get 1/3? Right. Because if I do my 13 minus 10, that means I'm 3 all the way across. And I'm 3. So that means I have to times them by 1/3 to get that total area of 1. Okay, so the next one says find the probability. Okay, so I would prefer a fraction, not a percent. So the probability that my 12-ounce coffee will not overflow, so everything less than 12. So what is the probability that I would be less than 12? So see if you can think of what that means. And I'll explain it. Take a stab at it. I mean, what do you say? What do you think? Two-thirds. Section. Okay, I want all this, so that's going to get me 2/3. So then what amount, so this time I need the amount, so this guy here, of coffee will be in the 75th percentile. So we're going to represent the 75th percentile as 0.75. Okay, I do base times height to get the percent. That's what we did on the last page. Okay, so if I'm trying to find my 75th percentile here, okay, I need to get some, I need to figure out where that is in my amounts of coffee. So what should I represent that as? If I don't know what it is. What can I put right here? Because technically it can be anywhere. X. So I have X. Normally I subtract 10. That's what I did here to find what that range is. So I'm going to do X minus 10 to do the area of the base. Alright. So that's like my base. Now I times it by the height. What's the height? 1/3. Okay, so area of the base, I need to figure out how long this is. So if I do X minus 10, I would get this. Just like if it was 12.5, I would do 12.5 minus 10 to get 2.5 as the base. That's why I'm doing X minus 10, to find what that actual length is. Okay, solve for X. Here's some algebra. For those of you that want the label, that was the height. I like to see the labels that I'm doing base times height. Make sure you label it so we know what you're actually talking about, like what information did you actually find? Okay, did I find a percent? Did I find an ounces of coffee? Did you do 3 times 0.75 and get 12.225? Would you want to divide by 1 sound and options. No, if you, here's where, okay, guys, let me throw it up here so you can actually see. You can do that, it just, you have to be very picky with how you type it in your calculator. Which if you're doing it in your phone, it's not going to work. Yeah, so you got to use parentheses. So for those of you that took 0.75 divided by 1/3, what you're going to have to do is 0.75 divided by 1/3. If you don't do it in parentheses, it's going to be 0.75 divided by 1 divided by 3, which is not the same as divided by 1/3. Okay, so that's how you're going to get that 2.25. So if you have fractions and you're dividing by them, you have got to put them in parentheses to say the 1 and the 3 are together. Okay, so I'm going to give you guys until 11 to try to get through 2, 3, and 4. So working with the people in your group, try to get as much done out of 2, 3, and 4. Then I'm going to throw the answers up before you guys leave for lunch so that you can clarify it. So go through 2, 3, and 4. And then when we get back, we'll do our normal distribution. So at 11 o'clock, I will start going through the rest of them. All right, I am gonna flip up your last set here. Take a looky. B is what I'm nervous about because if you find it, it says more than 3.75. So I'm not actually using the 68% because I want more than that. That is what that is, everything underneath it. So you have to be careful of what it's actually asking for, whether it's less than or more than. Okay. Once you have that flip the page, you're going to start up normal distribution before we head to lunch. Do I have any questions on this? Are we okay? Everyone's good? I heard over one. So I'm going to give you guys a minute to write all this down. So now we're actually going to start to see our symbols, and then I will kind of explain it. So lots of stuff. I figured it was easier to write it this way so you guys could read it again. Okay, so our normal distribution, so on our last distributions that we were doing, we could take whatever our total was and divide by the increments to figure out what increment percentage it was. When we're doing normal distribution, for a symmetrical bell curve, we have specific percentages that we're going to use each time. So it's not going to be 25% this time or 33% this time. Okay, we have specific percentages. So it's built off the mean and the standard deviation. So in IM1, you see this symbol. So in IM1, you would have talked about standard deviation with the S, and then you would have talked about the mean using this X bar. We're going to be using the mu more so than X bar, and you'll learn more about that if you guys actually go into AP statistics. They both mean mean, but one's for a specific set. So like if I did some sort of distribution with this class period versus the entire school. So I can find the mean of this specific class, or I can find the mean of the entire school. And when you have bigger sets of data, that's when we're going to use the mu. Okay. We also have our, similar to the standard deviation. So standard deviation is how much you deviate from the mean. That's how I kind of reference it. So it's how far spread out your data is from your mean. Okay. So we have different percentages in this. So normally you guys think, so here's my middle line right here in the middle. This would be considered the middle of it. Normally you think it's going to go 50-50, but it's actually a 68% all the way across. So what would just this part be? Oh, 34. So just realize we can break them down into halves then, which I think is on the next page as us breaking them down into halves. Okay, so this is my mu, or the mean of it. This is what we say is 1 standard deviation, 2 standard deviations away, and 3 standard deviations away. So this is mean. This is our data set. It's pretty close to the mean. And the further out that you get is my data is going to be further from that average mean. Okay? And then we have it to the left side as well. So we have our 68% is from the first standard deviation set. The second standard deviation is 95%, which is what's up there. And if you have the third standard deviation, that's going to represent 99.7%. So an example of ways to kind of put it on to a distribution graph, let's say my mean was 5, and I say my standard deviation is going to be 2. So I would go 2 this way, and I would go 2 this way. That's my first standard deviation. My second standard deviation, I would do 2 again. So he would be 1, he would be 9. So then this would represent that 68%. This next setup would represent 95%. And then if I did another one, it would represent the 99.7%. All right, so once you have that, flip to the next page. I think the next page is filling in a bunch of stuff again. I don't know how much I wrote on this one, so we'll see. All right. I got a couple for you guys to fill in. You have to write in. Kind of blends in. All right, so kind of talked about it. You guys saw me represented on the last page. This is kind of that mu, that mean, okay? That's considered our center. And then we have our standard deviations away. So that's my first standard, my second standard, my third standard deviation away. Okay, so then we have those percentages built in again. Okay, do you guys remember what the first percentage was for the first standard deviation? 68. So we got it, 68%. Of the 68%, blank percent of the data is greater than the mean, and blank percent is less than. So if I split it in half, what do we say was my left side and right side? 3/4. Because some instances I'm going to say, like, if I'm this standard deviation away, what percentage is it? And it's easier to kind of look at it as the half. What's my second standard deviation? 95, 95. So then what's half of 95? 47.5. You guys can kind of fill in the last one then. 99.7. Cut it in half. And then once you have it, flip to the next page. I'm going to do the first problem with you guys and then turn you loose for the last 4. I think 4. There we go. All right. There we go. So the useful lives of 10,000 batteries are normally distributed. The mean useful life is 20 hours and standard deviation is 4. So what number am I going to put in the middle? 20. How many am I going to go out each direction? Okay, put it out 4 each direction. Add 4 to the right, subtract 4 to your left. All right. What percentage of batteries will last between 16 and 24? What percentage was that? Yeah, it's my first standard deviation. Sorry, that percentage is covered. That means out of the 10,000, 68% of them would be between 16 and 24 hours. That's what the percentage stands for. Okay, so it says find the number of batteries that are actually between that. How many batteries are there? 1,000. And then we will multiply that times 68%. Remember, our calculator doesn't recognize percentages, so make sure you put it back into decimal. And that will tell you how many total batteries are actually within that first standard deviation. So those are all going to be a lot more clustered together in their times. 6,800 is what I got. Wait, I had too many zeros. 6,800. Let's try again. Like, how did we get bigger than 6,000? Okay, try the next two on your own. Go in your group. How are you doing? That's 9,500. All right, so I'm going to give you guys like 10-ish minutes here again. And then as I see people make it through the next question, I'll scroll down so you can see the answers. So once I see some of you guys start looking at the next page, I'll scroll for the answers to the next one. But if you guys are going to work on the next, I need like 4 examples. It depends. I didn't like the applied problems from first semester. I don't like any